Stat, what lesson is this? 3 point, what? No? 3 point, is it 3.3 yet? Or 3.3, I'm just going to put it as 3.3. 3.3. Measures of spread.
Okay, right there. Look. Okay, don't paper at me, please.
So, we have,
Guys, we have a lot to get through, so stop.
we know that, yeah, so we've already learned two measures of spread. We know IQR and range are measures of spread. So IQR and range are measures of spread. We have a new measure of spread that we just covered, and that is called the what? What was the one that we covered on Monday? Does anybody remember the name of the new measure of spread that we talked about when we were working through the Amplify? Close. I know what you're close. It's the standard deviation. Now, the symbol for standard deviation is, it looks like an O with a little squiggly, okay? It looks like an O with a squiggly. So mathematically, because that's a lot of letters to write, right? Writing out the word standard deviation every single time is a lot. Sometimes we might abbreviate standard deviation as ST, as SD. But mathematically, we use this symbol right here. And this symbol, does anybody know what this Greek letter is? It's a lowercase Greek letter in mathematics. It's very useful. It is sigma. So the symbol is sigma. But when you see that symbol, what does it mean? What does that symbol mean?
Standard deviation.
Thank you. Standard deviation. And what is standard deviation?
It's a range, a measure of a large spread.
Measure of spread. So, yeah, bigger values of standard deviation do mean bigger spreads. So it's a measure of spread. Now, I'm about to give you a very ugly formula that you're not going to like. But we're going to break it down in parts, in steps. All right? And we kind of did this through the Amplify. Here is the formula. Standard deviation equals the square root of, this is a squiggly E, parentheses, x minus the mean squared over n. It's okay. I'm going to break down all of what this means in just a bit. We're going to break it down piece by piece.
So the symbols we're going to define on our papers in a second, okay? So don't freak out.
No, it's a W in the middle. I missed it.
This symbol right here means what? What do you think that symbol means? Close, very close. It's the mean.
Yeah. You had to walk.
The symbol for this, the squiggly E symbol mean. Think about the work we did on Amplify Monday. What did we do? What did we do with the numbers that we found? Does anybody remember what we did with the numbers that we found? We added them. It means sum. In other words, add. So these two symbols are new symbols for us. These are three new symbols that we need to feel comfortable with when we read in statistics. All right, so we're now going to break it down into steps. Step by step by step. All right? So steps. To finding standard deviation. Okay, so step 1. Or sorry, step 0. Step 0. I'm going to make it step 0. It's going to change that part. Step 0. List the values. List all values. And we use the symbol X to represent the values. So let me add that in here. X represents the data values. The values. So list all the values. That is our first step. Step 1. I call it step 0 because most of the times we're going to list them for you, okay? Step 1. Find the mean, which is the symbol mu. Find the mean. Now we've practiced finding the mean. How do we find the mean? Does anybody remember? How do we find the mean? Add up all the values and divide by? Very good. So the mean is where we add up all the numbers and then we divide it by how many numbers there are. Add up all the values.
All the values that's there, not by two. That's
So
by the
wait.
meeting.
Okay, guys, make yourself a note on your paper. You can draw an arrow that's pointing to that you're looking E, and just remind yourself every time that's just words that mean to add up all the values.
Add. Let me change the color here. I'll put it in a. Add values, then divide by amount. That's how you. Sorry. What was that question? Sure. Add values, then divide by amount. So that's how we find the mean. Step 2. Find the deviations. Now, does everybody remember what the deviations were? What we said that was from? How do we find a deviation? Or what does it mean to be a deviation? How far you're away from the mean. So it's X minus mu. X minus the mean. So we find out how far each of the values are from the mean. And it could be positive, they can be negative. Okay? Step 3.
Divided by the amount of numbers.
Square the deviations. Square the deviations. So X minus mu squared. Square all the deviations. Remember we squared them all and we found how much each number was squared? What did we do after we squared the deviations? Squared deviations. Okay, now this has another vocabulary word. This is also known as what is known as the variance. I'm going to write that word in there, finding the average squared deviations. That is called the variance. It is not a term that we are going to be pushing on you yet, but it's something that I want you to know. And so what we do here to do this is where we add all the squared deviations and divide by n. So I'm going to put in here, and again, we're going to practice this. So add the squares and then divide by amount of values. And finally, step 5, the last step. What was the last step that we did? After we found all the values, we found the averages, what did we do, Trey? What was our last step? We take the square root. Because we squared all the values, at the last step, we're going to take the square root. Find the standard deviation by taking the square root. So this is where we take the sigma equals the square root of what we just got. Okay, and I'm going to pause there. Now, I do have a little bit more to add, but I hear a couple of things I want to note. We divide by n. It is possible that you look up on Google, you do a ChatGPT or whatever that you're looking up, and you're looking up standard deviation, and you see a formula that has n minus 1 on the bottom. Please note that we are not talking about that one yet. That is going to be a formula that we use later in the course. Like I'm talking February, March that we'll use. So we are not going to be using this. What we're finding is what's technically called the population standard deviation. For us, it's the only thing. It is the standard deviation, okay? So if you see a formula with n minus 1, you can ask us, what does that mean? We'll give you an answer on the side, but it's not something that we're going to be testing your knowledge on yet. So that's a step. We're going to practice this in a little bit. We have it in your homework handout. We have that. And again, we want to get to this as soon as possible. I'm going to wait one more minute while this is up. I have about just a couple of more lines of notes to add, and then we're done. No, I have a couple more lines. All right. When I said I'd wait one more minute. I think we've got some minute. So, best measures of spread. Best measures of spread. Okay? If the data is symmetrical with no outliers, what is the best measure of spread to use? What do you think? So when the data was symmetrical, no measures. Remember, our measures of mean, of center, are mean and median. So which of those two is better when it's symmetrical? It's on the back of the homework handout. The mean. The mean is better because it's non-resistant. Okay? Now wait a minute. If you look at this, the standard deviation formula is calculated from the mean. You need to use the mean to find standard deviation. So as such, when you're using the mean, you should also use the standard deviation. So when the data is symmetrical with no outliers, the best measure of center is the mean. The best measure of spread is the standard deviation. They're linked together. If you're going to describe the mean, you describe the standard deviation. One is for center, one is for spread. Skewed with no outliers. Skewed with no outliers. What are you going to use? I'll put 2 dots here to give you a hint. If it's skewed with no outliers, what are we going to use? Well, that's what we use for center. So what do we use for spread? What is calculated from what's a close relative of the median? IQR and range are both okay. Those are measures of spread. And finally, the last part of the notes, if the data is skewed and there's outliers or outlier, then we can only use IQR. Because the range is not going to be a good measure. When you have an outlier, it's going to really throw off that value because the range really is really affected by outliers. So that is our notes from today. We're going to spend the rest of class working through this homework assignment. It's mostly focusing on the front of it where you're going to practice calculating the standard deviation. So you can go through the process. The back side of the homework is going to ask you questions on this. You're going to be given histograms, dot plots, stem plots, and it's going to ask you what is the best measure of spread. It looks like the same one from your homework. You are correct. It is the same problems from the previous homework, but the question says spread. The last one said center. Okay? And we're not doing it with Trevor.